Hey, what's up everyone, and welcome back to another video. Today we've got a fun one. We're going to be walking through 100 pandas puzzles, and these range from easy to difficult, so great learning opportunity for anyone that wants to boost their pandas skills. We'll specifically be working off of this AJCR 100 pandas puzzles repo, so that's linked in the description. Shout out to the person that put this together. So this will be what we'll be working off of. And I encourage you, as you go along this video, try out these exercises on your own. And if you want to see how I would approach it, then you can resume the video and kind of follow through with my solutions. But I'm going to go ahead and fork this repo. Create fork, just so I can commit to things on my side. And then I'm going to go ahead and clone it. So open up a command window. Let me go into my, I think I have a folder called code. I'll make a directory called pandas exercises. And in that we will do a git clone, and we'll paste in that link that I copied via this. Perfect. So now we have 100 pandas puzzles. And you can go ahead and either open up a Jupyter Notebook this way, or you can also, if you prefer to use like Visual Studio Code, we can open up our code that way. For this tutorial, I'll be using Visual Studio Code to play around with my notebooks. So I'm going to open. I'm going to go into that code folder I created, go into pandas exercises and 100 pandas puzzles, open that up. Cool. And we can see we have the notebook here. And you can start reading through the exercises. There's also 100 NumPy exercises, so we might do that in a future video if you enjoy this one. But it starts easy, gets harder. You can read through this. But let's go ahead and try some of these out. I think we'll knock out these first few ones pretty easily. Feel free to pause the video and resume when you want to see how I would approach this. All right, import pandas as PD. Looks good. Check out the pandas version that has been imported. PD dot, is there a version? Looks like we could do this. 2.2.0, that seems about right. You should expect to see above 2. It's above pandas 2 as of this video recording. That looks good, and I guess if you really wanted to, you could print this, but it will also just display it automatically. Same thing. Print out all the version information of the libraries that are required by the pandas library. We're getting into the technical weeds here a bit, and this is the type of thing I'd probably just Google typically, but I think we can go ahead and do probably pd.dependencies maybe. Let's see what happened. Built-ins. What's in here in the underscore stuff? Is there a dependencies? No. What's built-ins? Oh, that's just like built-in functions. I don't think that's exactly what we want. Is there requirements? Okay, I don't know this off the top of my head. I might just Google this. Print library dependencies, Python. Find pandas dependencies. List Python. How do we figure this out? This looks print pandas dependencies Python. Looks like pd.show versions we can do. All right, that was more difficult than I feel like it should have been, but it's not something you do in practice a ton. That looks good. Cool. Okay, I think it's worthwhile just checking these solutions here, the first 3. And there's multiple ways to do a lot of these things, so I wouldn't necessarily say there's one right or wrong answer. So curious how this is run. Yeah, it looks like we got all 3 of those. Okay, let's keep going down. Just trying to make this as large as possible so it's easy to read this stuff. Okay. Okay, create a DataFrame DF from this dictionary data, which has the index labels. df equals pd.DataFrame. Luckily we have, and so our data is going to be data. Can we set an index here? Index equals labels. I think that's all we need to do. We can run this, command enter, control enter, and then go down here. Okay, and this here, the summary of the basic information, I could just call df.info. This is just something you kind of remember with time. This is probably what we're looking for here. And then return the first 3 rows of the data frame. We can do df.head by default. df.head returns 5 rows. So if you want to pass just 3, we can do df.head 3. We get that. And we do see ABC as our index, which is what we were looking for. Select just the animal and age columns from DataFrame. What the heck, light? Might be. We're back. I don't know. Being too stationary, I gotta stay on my toes. All right. Just animal and age from our data frame. We can do df. And I don't know if it wants to set it as a new data frame or not, but the easiest way to do this is this double bracket syntax and age. So it's basically passing in these columns. Control enter. That looks good. I hope that you can all see this well enough. Go to Zen mode, is that better? I don't know if Zen mode's better. Ooh, I kind of like that. Okay, now is that any different than what we just had? Okay, whatever. That looks good. Okay, I'm going to set this as like df new or something. Or maybe I keep it as this. But you could always set it to another data frame. And you could like copy if you didn't want to replace the original. Now we're getting into interesting stuff where we could use loc and iloc probably. So I might use this to get just those columns, but then I might be able to call iloc, and I think we could pass in 3, 4, 8 here to get index rows. Guess not. Or maybe I had the wrong axes. What is the default axes here? Yeah, it should be good. I think I called it wrong. Okay, so we can do df. I always forget iloc and loc, to be honest. Animal, age, and then we can do iloc, and then we pass in 3, 4, 8. That should be what we want. So we should get, I think this is 0, 1, 2, 3. So we're going to probably get this, this, and 6, 7, and this. Let's see if we do. Dog, dog, and dog. What was this, 8? 0, 1, 2, 3, 4, 5, 6, 7, 8. That looks good. Perfect. Okay. Select only the rows where the number of visits is greater than 3. I think now we're going back to our original data frame so we can see the head of that again. And so visits greater than 3 would be df dot visits is greater than 3. That's one way to do it. Show that. Is there no visits that are greater than 3? I find that hard to believe, but let's just look at our data frame again. Looks like there is no that is strictly greater than 3. Another way we could have done this is we could have gotten the column like this with this bracket syntax. Same thing. All right, select the rows where the age is missing. Okay, so let's see. df.head, age is NA. So we want to do df, filter by age. I'm going to do the dot syntax again, but again, remember, dot and this, same thing. This is more robust because if you had spaces in your column name, like let's say it was age of animal or something like that, you could do it this way, whereas I don't know what the equivalent dot syntax is. Maybe it's like, I don't know if there's I don't know if it automatically does underscores or not. Worth checking. df.age, and then I think we can just do .isNA. I think that will give us what we're looking for. Look at that. Perfect. Select the rows where the animal is a cat and the age is less than 3. All right, now we have multiple conditions. So df, when we have multiple conditions, you want to separate them in parentheses. Animal is a cat, so df dot animal equals cat, and the age is less than 3, so df dot age is less than 3. You can run this. Look at that, we got it. Cool. Select the rows where the age is between 2 and 4 inclusive. So we want df.age is less than or equal to 4, and df.age is greater than or equal to 2. We're going to get an error, I think, when we run this, because it doesn't like multiple conditions without the parentheses separating them. There might be other ways to do this, but this is how I at least approach these multi-condition filters. Run that. That is inclusive. We can double check. I'm going to do a command / to comment that out real quick. Let's just look at our data frame again. Yeah, there's not even any. Oh, there is one cat that's 2. So let's just make sure that we have that 2 example when we output this. Oh no, what did I do? Perfect. We see that we get the cat with 2 there. Change the age in row F to 1.5. Okay, so we specifically, okay, this is what threw me off, I think, before with the loc. Let's real quick just look up loc docs pandas. I always get a little bit. Okay, so it's gonna, loc is hitting the index here. So loc, in this case we had like df.loc, okay, sorry, I can't even speak. When we use df.loc, so when we did df and then brackets and then had those multiple like column names like animal and age, that was getting these columns. But if we specifically want certain rows and we don't want to do the rows by their actual index, so like this would be 0, this would be 1, this would be 2, but we want to use the actual index name, that's where we're going to use loc. Good to remember that. So we want to do df.loc of f. We see we get the cat with age 2.0 here. That corresponds to that. So I think we can do equals. I think we can do loc f, and then I think we can do age. Then I think we can do equals 1.5. Let's see if that works. It's not loving that because we're setting it on a copy. Let's think what this actually looks like. Does loc by, does this return a copy by, what is the return here? We might need to double check this. What we can do real quick though is we ran that. What happens if we just I press B to create a new cell below. What if we look at the data frame again? See, yeah, it's not set in the original data frame. So we have an error here. So this must have made a copy at some point. I think if we do df-loc f and we get specifically the age column and do it this way and set it to 1.5, I think that this works. OK, no errors there. So this is and we see we get 1.5. So sometimes, yeah, you got to be careful with how you do these things. There was a slight difference there that when we broke this out and didn't do df.loc and access that age column specifically in the loc function, we actually made a copy of our value, and then it wouldn't actually set it to 1.5, so we have to do it this way. Good to know. So yeah, look at the warnings you get, because that I wouldn't have known if I didn't see that warning. Calculate the sum of all visits in the data frame. df.sum. I think we can just do df.sum. Yeah, and then we could specifically get visits. There's other ways to do this, but this is a simple way, and that gives us, I think, the correct answer. We could double check by, again, looking at our data frame and just doing a little bit of manual math. 1 plus 3 is 4, 6, 9, 11, 14, 15, 16, 18, 19. Yeah, correct. There's other ways to do this. Calculate the mean age for different animals in df. We can do again df. I think there's just a mean. As you can see, it's auto-populating with Visual Studio Code as an option. Oh, and it specifically mean age for each different animal here. So we have an extra step. Let's look at our data frame again. Animal. So we're going to first need to do a group by. And we want to group by why is this? Stop turning off on me lights. I think we can just do age. I always kind of forget this too. What we could do is look at documentation and see what they're doing. OK, I need to do it in brackets. I think. We'll see. We'll try it twice. Group by age, and then we want to do the mean on that. I guess not. We can call this aggregate. OK, and then we can do by mean here. Maybe this is the way we want to do it. I think group by followed by ag is kind of a good approach. All right. I might look this up, but another trick, if you have GitHub Copilot installed, is I can do Command I, and I could even just type something in like group by age, and then calculate the mean for each. Oh, why am I grouping by age? I wanted to group by animal. Maybe that's my issue. It's not, but Command I, group by animal, and then take the average age of each animal. And it might be an issue because there's other fields that are non-numeric, so maybe I would have to only get age here or something. Let's see what happens there. OK, that worked. But I am curious. Let's say I removed this line. What would GitHub Copilot do? Group by animal in my df, and then take the average age of each animal. Yeah, so it specifically filters by age. So we could run that, run average age. That looks good to me. You could call like RecentIndex too if you wanted to get values back. So Mean worked. You could also use the ag function, and then you could pass in, sum. You could pass in mean. So ag is a little bit maybe more robust, but we get the same answers. If I call RecentIndex, what happens? I feel like that should reset to, maybe it resets to the default without the labels that we had originally. Cool, 15 done. Append a new row K to DataFrame with your choice of values for each column. Then delete that row and return the original DataFrame. Okay, we got a couple steps here. DataFrame looks like this. We want to add a new row, so we could do df.loc. We want to specifically add something called K, and we want to add all values. So I probably could do K equals, and then we could either probably pass in a dictionary, or you probably could just pass in, what's a monkey, 3, 2, and yeah, it's a priority. Yes. So let's see what happens if we do that and then run df. Yay, we get the monkey line. I'm curious what would have happened if we did this as a dictionary and did like age 3, animal, monkey, visits 5, and maybe even left out priority. What would happen there? Cool, that would have worked too. So those are two different ways. And we can see, K is changing. Though that was two different ways we could do it. This way here with the dictionary is a little bit more robust because it doesn't rely on us having to get the order right. So what happens actually if we delete this row and then call df? Yeah, so that's still there. So now what we need to do, I'm going to copy the original values I think we had. It was monkey, I think it was like 2, and then 3, and then yes, it's priority. What we could do is then a drop. I think if you just, is this, okay. Drop. Okay, I think we can just do that. See at df. K is still there. What if we did drop K in quotation? I think the issue is it's trying to drop a column right now. So what if I said index equals K? Okay, I think it just, because I used a capital, it got mad at me. Index equals K. What happens there? Why are you still showing me monkey? What do I put this in brackets? Oh, it's not doing it in place? What if I pass in place equals true? Now, okay. Now it actually drops it from the data frame. I could have also done df equals df.drop, and we'll see if I get rid of this in place. It's also not there. But if I just did this, then it's returning the data frame without that row K, but it's not setting it to anything. So two different ways you could have done that. We'll keep the in place equals true. Cool. Count the number of each type of animal in the data frame. Okay, this is another group by. Group by. And this is a weird one because we need to do group by animal, but there's no like easy way to get the counts because we want to like sum. We want to sum like 1 for each value here. So I wonder if one of the ag functions is like value counts. Can we call value counts after we group by animal? I'm not sure. worth trying. One thing that I sometimes do is I sometimes add like a count variable, and I just set that to equal 1 everywhere, and then I do something like df group by animal, and then I get the count, and I sum that. So like we'll see that this works as far as counting them goes. I wonder if there's a better solution here. I might pause here, and let's actually maybe just look at what the solution says regarding this one. Looking at solutions, test. Oh, they did is null instead of is NA. That works too. Ooh, between. That's a nice little function to know about. This looks the same as what we did. This looks very similar. Oh wow, df.drop k. They didn't need to. I guess I just needed to set it. I didn't need to specify index. Oh, they, wow, why did I do group by? I could have just done value counts. I knew that that was the play. Okay, that was silly. Alrighty, back to this. Sort df first by the values in the age in descending order, then by the value in the visits column in ascending order. Okay, so row I should be first and row D should be last. Let's just look at our data frame again. Row I should be first because age in descending, so highest age first, and then visits in ascending. Okay, so given ages descending, visits in ascending. All right, so we can do .sort values, and then we can by, you can pass in a list here, so we can pass in by age, and then pass in visits. And then the tricky part here is we need one to be ascending and one to be descending. And then, so what we can do is I think we can pass in ascending, and that actually can be a list as well. So the first one, and it's a list, and you use a boolean value to specify, so that it could either be 0 and 1, or you could do like false, true. So the first one's descending, second one's ascending. So I think that this should work. And it's dark again in here. Run that. I is the first column or first row, and D is the last. That works. We could have also done 0 here and 1 here. See that that also gives us the same. But if I just did this, yeah, we don't get what we wanted because it's not doing the ascending stuff correctly. Need more light. Whew! Let's go. Okay. Replace this column with a column of Boolean values. So real quick, we're going to do df.info on this. We see that this is object type. I think that there's an actual Boolean type. So what happens if we did df Boolean equals true? What type of column is this? Just say, see, that's a Boolean column. So we want priority to become a Boolean column. Oh, I actually want to drop count too. Okay, we're back to this. So how can we do this? Well, priority, we want to do like replace, and we can do a dictionary here. We're going to replace yes with true. Why are you going so slow right now, computer? And no with false. So we could say df equals df.replace, right? Now what happens if we look at, cool, but if we did df.info, the issue is, oh, wow, it automatically realized and changed it to a data type bool. That's cool. That is cool. I thought it might keep it as that object type, but sees that it's a more efficient Boolean data type there. Awesome. That was the line we needed to run. In the animal column, change the snake entries to Python. Heck yeah. Again, this is a simple replace. We could do replace. We could take, oh, and I guess we specifically should have done df. Like we should have specified a specific column here. So df animal. It didn't matter because there was no yes or no's, but this would have done it on the whole data frame instead of just that one column. So df animal.replace, and we will change this time to snake to Python. And I'm going to do an in place equals true here, just so we don't have to run like a df equals command. Cool. And if we look at this, we see Python and Python, specifically for that animal column. Cool. That looks good. For each animal type and each number of visits, find the mean age. In other words, each row is an animal, each column is the number of visits, and the values are the mean ages. Hint, use a pivot table. Nice. I always forget how to use pivot tables without reviewing them. But they are super useful. They're good to know. So df.pivot table. All right, we want our rows. What are the, I always just forget like which is which. That's my issue. But I think if we look at our, oh, no, the docs here, the examples are always super helpful. All right, values equals d. Okay, so we want index, columns, and values. So in this case, oh, and ag function. Okay, so this is helpful. Values is going to be age. Our index is going to be equal to the animal. The columns is equal to visits. And I don't know if these have to be functions or not, or arrays. And then finally, our ag function is equal to mean. What happens if I do this? I think it's going to give us an error because we don't have these in lists. Oh, wow, it worked. OK. For each animal type and each number of visits, does this look right? And I always like to, yeah, double check, did we do this correctly? So I'm going to make a new cell real quick. And this would have been the same if we did like these as lists. So index could have been animals. Columns could have been visits. This is the more robust way if you have multiple values here. So if I run this again, we see we get the same thing. But df, let's just do it for one of these use cases and see if we get the same average age. So looking at specifically visits equals 1. All right, filter by that. So there's a little bit of a question on what you do with not a numbers. But we do see that, like, yeah, this is only one example, but it is 4.5. There's no multiple examples. So what about visits 2? Maybe that's more interesting data. So we should get 6 for dog. We do get that. OK, this looks good. It's just a matter of what you do with the not a numbers. But I'm happy with our solution. All right, data frames, beyond the basics. All right, may need to combine 2 or more methods to get the right answer. We can do this. Ooh, this is a fun one. How do you filter out rows which contain the same integer in the row immediately above? So we got df. The thing that's frustrating is we still have our old df. Let us run this cell. I'll just do df. I'll just copy this. Oh, actually, they're making it. No. OK. We've got a new data frame here. So I think there's like a window type function. I forget what these are called. df.window. Maybe it's df.rolling. What does rolling do? I think our window here is 2. What happens if I set this? I'm a little lost here. Okay, it doesn't like that. This might be a Google one or a Copilot one. Pandas check columns next, or check rows next to each other value. No. I think we want window functions. That does sound, pandas window functions. Okay, so this would aggregate things next to each other. How would we drop? There's like easy ways and more like pandas ways to do this. Like the easy way would be to iterate each row and like just drop rows that are not like that are the same if they're consecutive. What is a more Pythonic way and pandas friendly way to do this? So very simple solution would be like for row, for index row in df.iter rows, you could do like basically like check if row, A equals row index row.iloc index +1 like A. Then you drop that second row. So that would be one way to approach it. I don't like that though. I wonder what would happen if we just did a GitHub Copilot. Check if values in column A that are next to each other are the same. If they are, drop the second value. Pandas. I don't know if is duplicated right here. We get 1, 2, 3, 4, 5, 6, 7, which looks good. You want to be careful though, because I don't think that this is right, because if we did the example like this, we should have a 3, it should be 1, 2, 3, 2, 4, 5, 6, 7. So watch what happens if I run this, but it's going to drop all of those extra 2s. Yeah, see, gets the same thing, but we added 2 extra 2s. So duplicated, this doesn't work, this duplicated method that Visual Studio, or the GitHub Copilot recommended. Pandas drop row if row right above is the same. How to delete row which have same value of row above in pandas. Ooh, looks like we can use this shift. Look at that. This is how you kind of do these things. Is like, you're not gonna. Most people won't know everything, immediately, just from pure pandas knowledge. So you sometimes look things up, and the interesting thing here is that, the AI tool couldn't really help us as much as just good old Stack Overflow can here. But I like this. I like using this. Let's make it our own. So I'm going to just paste this in. So we want, this is now A, df_A. I think this will give us what we want. There's always like weird edge cases here, but we'll try this. Okay, that didn't work. Oh, this is not setting it to anything, so df equals. Oh, actually we need to do df, and then we want to mask by this. So what does that give us? That looks good. And let's try to think through how this is working. So we have this array. It's getting the value, and then it's looking at the value that is shifted. So let's take this, 1 and 2. Well, 1 is not equal to 2, so the shifted value, this would be not equal to, that would be true. So we would keep A in that case. Next we get to 2 and 2. Well, we look at dfa, that's 2. We look at dfa shift, that's going to be the second 2. So that is equal to each other, so that would be false. So that would get, this 2 would get masked out. Next, you get to 2 and 3. 2 is not equal to 3. So this 2 would be kept. This 2 would be kept. I'm trying to think, is there a weird edge case here? Like this situation here without that second 7. Or is it shifting upwards? Let's double check. Oh, interesting. So if we shift periods equals 3, shifts things downwards. I think what's worth looking at is if you just created a new column called shift and set that to df equals dfa dot shift, and looked at what this is. Okay, so that shifts it downwards. So the first one, okay, so it is the order that we expect. That's good. Because first index, the shift one is an NaN. Second one checks the 1 that's right above it. Okay, so this works. I thought it was going the other way and there was a weird edge case. We're good. Don't worry if you didn't understand all of my rambling, but hopefully you kind of understand how this works. Worth probably checking at this point how the solution looks for this. That was like 22. Yeah, they did a shift, so pretty similar. Yeah, and drop duplicates wouldn't work exactly kind of for the reason that we were talking about with the 1, 1 at the end, because those would get dropped in addition to the correct 1 getting dropped in the first example. Drop duplicates here would screw things up. How do you subtract the row mean from each element in the row? So let's think about what that means. Probably worth actually copying this code and running it real quick. Okay, how do you subtract the row mean from each element in the row? So the row mean would be these 3 numbers averaged together. And you need to subtract it from each element in the row. So df equals, and sometimes this type of thing, it's easiest if we don't start with this random. We start with like values that we know about so we can know what it means to do row mean. So like what if we did, can we do NP, I think we can do NP1s. Watch this. Does this work? So this is a simpler example to start. If we subtracted the row mean, everything should become 0. So we could kind of confirm that we're doing this right. So if we just did df equal is df minus, let's think, df.mean axes. By default, I think it's 0. Does it show me a default? Defaults to 0, so as we can see down here, defaults to 0 is defaulting to the row average. So what does this give us? And then do df. Oh, I don't need to provide axes because it defaults to the right one. Look at that, that worked. Cool, so if we then just did, yeah, I mean, this is ultimately our solution, but we confirmed it with an example that we knew was right. Okay. Suppose you have a data frame with 10 columns of real numbers, for example. Oh, I'm sorry, I should technically probably copy this back in. Suppose you have a data frame with 10 columns of real numbers. Okay, and again, this is like very tricky to do off the bat. Ideally, we see that we have like a very simple example. So like we could again do np.ones of like 5 by 10. Okay, and we could say something like df, let's make the letter E equal to 0. Now if we look at our data frame, we see we only have one column of zeros. So which column of numbers has the smallest sum? Well, we can do df.sum axes is going to be columns in this situation. And then we can see what happens with that. Oh, that's weird. We might have screwed it up the other right here. This is still going to be correct, but my example might have been backwards, where we maybe actually wanted this to be axes equals 1 here, because this is I had the summing off. I didn't understand what it meant. And then to get the columns label, let's think how we could do that. .min, what happens? Is there like a min label or something? .min. So we know it's E in this situation. How do we dynamically figure out smallest value? Min sort index, maybe? What does this do? There's a new series sorted by label. Oh, I guess we could just always, what happens if we just sort values? Okay, now E is first. And then I guess we just do df.index or df. Okay, here we go. Sort values, and then we want to get the index of that first spot. So then we could do like, iloc 0.index. That would work. So this should give us E. Index 0 would work. That would give us E. I kind of like getting the row, though. I don't know why this didn't work. Okay, now that gives us, okay, there we go. That works. A couple different ways here. I'll go with the index 0, I guess. That was the simple enough way to do it. What does the actual solutions tell us here? Index min, oh, interesting. I didn't realize there was a function like that. It looks like they did a slightly different way here. So there's no one right solution. There's multiple solutions to these things, so it's always worth checking out how things go. One thing that's interesting, though, is that we did realize that the axes should be 1 here, so we made that fix. All right, let's keep going. How do you count how many unique rows a data frame has? As input, use a data frame of 0s and 1s with 10 rows and 3 columns. I feel like most of these, it's like more helpful like you kind of want to do it, load in your data frame, see what the data frame looks like, and then run the actual command with that data frame just so you know what you're working with. This is unique, this is unique, this is unique, this is not unique, this is unique, unique, not unique, unique, not unique, not unique. So I feel like there was like 6 there that were unique. So we could just do df.unique, I believe. Let's see what that gives us. Guess not. Am I crazy? I thought it had a unique. So columns have unique, but not df. I mean, you can just drop duplicates, I guess. What does this give us? Look at that. Cool. That was easy enough. On specific columns, you can get unique values by doing like df1.unique. That should just give us 0 or 1. Yeah. Cool. So it was df.drop duplicates. That was our simple solution here. Should be all there is to it, really. And I guess if you wanted to, you could do df equals like df.drop duplicates or in place equals true here. The next 3 puzzles are slightly harder. For each row of the data frame, find the column which contains the 3rd NaN value. This is weird. How do you do this in a Pythonic way? Okay, so we got this. In my head, it's like we want to maybe drop duplicates. Like, what are the options with dropping duplicates? Is there like a... What is... There's just such a weird 3rd NaN value. What are our index options? IDX. I feel like we want to create like a new data frame of the indexes of the same size and like sort it. Not the index, it's the columns. You could like pivot this. Like, I'm thinking like, watch, invert is one thing I'm thinking about. What's it called in matrix land? Swap rows and columns for df. Transpose, that's what I was looking for. df transpose. Like, is this helpful? Because then you sort index. What happens here? I'm just kind of freewheeling here. That's not what we want. Oh, we could sort values here. That's not really what we want either. Does the transpose help us? I feel like we could probably, it's probably like a count duplicates or something like that. Let's go use some Google search here. Count occurrences in a row. Pandas. Not exactly what we want. There's like always an easy way to do these things, but I'm trying to think of like the Pythonic way. It's easy to do if we iterate row by row, but I feel like there's a more elegant way. I could. Honestly, I am a bit stumped. Let's do the really not elegant solution. Really not elegant solution would be for row index in df.iterRows, and then you could just like print the row. I'm going to break out just so you can see just one single row real quick. I guess I switched this. It should be index row. Okay. And then you could do like for label in row, print label. And you could even do for row dot enumerate. Print value. Then you could very easily get the third NaN. Labels equals row dot columns. Labels, this is so not a good way to do it, is df.columns. For I in range row. Label equals row I. Value, we'll say value equals row I. And label equals labels I. And you count the, oh, this is so not good. It's like, this is so ugly. Count equals 0.
like this, and then basically if value equals 3, or if count equals 3, outputs dot append label outputs equals this, and then you could do like pd.series of outputs. Really not a good way to do it, but let's see what this gives us. Print label that looks good. I think we could do if value, if not value. Like, I don't want to do, maybe this would work. This is getting so ugly. Print like they're saying that this is true. That's so weird. This is not a number though. You could do fill NA as like -1 or something. I hate this. Value equals -1. This will work, but it's so ugly. All right, this is called It Works, but this is the ugliest solution you could find, and you should definitely make it better because this would not pass the test. Oh, and this should get to here, it should continue. That continues in that loop. I guess you should break out of this loop, and then hopefully the next, there you go, ECDHD. ECDHD. So ugly, oh my gosh, how can we make this better? I might just look at the solution for this one. is null, cum sum. Okay, df is null. What does this function do? Okay. Okay, this makes sense. Cumulative sum. That's very useful. Let's just see what that looks like in practice here. All right, so what does this look like? Let's just look up our data frame again. We get this. So cumulative sum, and let's say we filled NA with 0 here. Okay. If we did cumulative sum, let's call this A. And let's look at A again. If we did cumulative sum on A, we're going to get 0.4, 0.4, 0.4, 0.29 in the third place. So we're going to call cumulative sum. Okay, and that looks like it's running the wrong way, so we're going to make axes equal 1. Okay, so see 0.4, 0.4, 0.4, 0.29. So what this solution did is it said, okay, we have our data frame. We looked at what is null, so is NA. So we're going to get B is true, C is true, etc. Right? And then you called a cumulative sum on that. And if these are booleans, false is equal to 0, true is equal to 1. So if we call cumulative sum on this, axis equals 1, we'll get 0, 1, 2, 2, 3 here with E. So 0, 1, 2, 2, 3. 0, 1, 2, 2, 3. And then it basically said, okay, we want to filter our data frame by when this is equal to 3. What does that give us? Go back here. We need only the did I just call index max on this? We want only the want to go back to the... What does this return us? Oh, okay. That makes sense. Oh, and then you call index max and you can set axis equals 1. Interesting. Okay, there we go. I didn't realize we could call index max and use axis 1 to get the max index on the, whatever you call it, the column names. That was really kind of difficult.
All right, let's keep going. Let's do number 27. A data frame has a column of groups, and a column of integers values. For each group, find the sum of the 3 greatest values. You should end up with the answer as follows. So I feel like in this one, I see it as like a sort by group, or like group by the group, then sort by highest to lowest, and then I think I can just sum the first 3 of each group. It's kind of what I'm thinking. Let's look at DataFrame. So what happens if we just do like sort values? I think we can do like a multi-sort. We could do sort values, and we could pass in a list here. Groups, and then vals. And the ascending here, we would want the first one to be ascending true, the second one to be descending. So what does this look like? That looks pretty good. And now it's just a matter of sum the 3 greatest values. So how could we just get the first 3 values for each group? We could do a cumulative sum and then just get the 3rd index. How would we even get that index? What are other solutions here? Let's do a cumulative sum. I'm just trying to get... Let's see what happens if we just do this. I mean, we do a cumulative sum on the... Maybe we have to group by. Can we cumulative sum that? Then we just want to grab the values. Honestly, this is the type of thing I feel like we should just go to the documentation. Just want to see what functions we have available. I'm going to just look up something like drop values after 3rd occurrence, pandas. I like the idea of using cumulative sum somehow here. But we want to do it on... I mean, part of me wants to like pivot table this. Let's see what would happen if I do this. Our columns equal groups. Our indices are the same. Did it automatically sum these things? I think we got to do rows equals index or something like that. Oh, this is weird. Maybe one way we could do this is like map the occurrence of something to a new column. I'm going to try something here. Create a new column count which represents the count of a specific group's value that has occurred thus far in the data frame. Oh, this looks good. This looks promising. And now we could do a cumulative sum on this. There's probably a better way to do this. Okay, now we can do a pivot table. df pivot table. There's probably a more elegant way to do this, but now our columns equals groups, our values equals vals, and our index equals count. Watch this. That looks good. And now if we do a stop that. df equals that. Now if we do a df dot cumulative sum of this, and then we basically just want to take the third index. So what does this give us? I need to be reminded of what it was before. So this one should be, that's 397, these first two rows on A, 397, 399, 409. So this should be 409 here if it's adding downwards. Yep, cool. Take that. Now we just want to grab the third loc position, index 3, which is weird because it's count is the index, but this is technically, I guess, the actual index integer-wise of 2. But I think if we do loc 3, let's see what this gives us. It's what we want. And what does it want returned? That looks good to me. I wonder if there was a more elegant way to do this, but I'm content with this solution. This cumulative count was a helpful thing in kind of defining this extra count column, but there's probably a more elegant way to do this. Keep moving on. The data frame df constructed below has two integer columns A and B. Values in A are between 1 and 100 inclusive. For each group of 10 integers in A, calculate the sum of the corresponding values in column B. I'm kind of confused by this. Let's just look at what our data frame looks like. Got to import NumPy, I guess. For each group of 10 consecutive integers, for each group of 10 consecutive integers in A, I'm so confused. Oh, okay. It seems like A is not even important at all, though, here. Am I crazy? I feel like this is probably a window function where you add 10. But I don't get what A is being used for at all here. Or rolling. Window equals 10 dot sum. Let's see what happens here. Okay, this is the first 10. So we should get 399 after the first 10. Is that right? 399. So with this rolling thing, at index 9, I guess, we should get 399. Let's get the head of this. Oh, head 10. Oh, look at that. It gets 399. And now we just need to convert these indexes to like the corresponding groups, I guess. It's inclusive. So how could we only pick every 10th row? We could do something like dfb equals df.rolling window dfb rolling window 10, and then I think we can do something like df.loc and only grab. We want to go from start to the end every 10 objects. I think we can do this syntax, which basically means go through everything but iterate, jump every 10. And we want columns A and B, but I think that we can just do this. Okay, we're getting, that looks better. Why did this not like how we set this? Oh, because we just did head 10. So we want to do dfb equals this. Then let's see what happens if we do this. Okay. I kind of feel like we want to shift it by 1. I feel like this is close. However, what the heck? Oh, like, are we taking the index? I'm so confused. Like, is this index 46 and it wants me to sum that with? I think it wants me to do something else other than what I thought it wanted me to do. I think it wants to take index 46 of B and sum that with then index 75. Okay, let's try this. How do we do that? I feel like we want to reorder this so we can sum it more easily. Like create a new column. Call this C, and that's going to be equal to df. We're going to grab B, iloc list of df A. Basically, get all of the indices, index that into B, and then set that to C. Oh, this should be brackets. Positional indexers are out of bound. I don't think they are. What happens if I just do df A? What if this is just loc? It's kind of crazy, but I feel like I have to like subtract 1 from each. What happens if I do this? Because 1 to 100 inclusive, this ranges to 99. So I'm going to keep what we just had. I don't even know if we're doing the right, and do this. iloc, I bet you this will work. Oh, this all makes sense now. I feel like I need to sort this first. Basically sort it so it's 0 to 100. I'm going to sort by A. Now this is, okay. We're now adding this based on these conditions. So how do we group this? Okay, this makes sense. So basically, I think we want to add a group column or something like this. Groups equals I to I plus, we'll make this an F string, I to I plus 10. This is a square bracket for I in range 0 to 100 by 10. Now if we print out groups, we get this. That looks good. And now it's a matter of doing the summation on the sort values. How would we do this? I want some sort of mapping that we can easily group all of these to. Let's make a new column. We'll call group. And the group will be, we could do some sort of like floor division or something here. So if we multiplied every number by 10, this is tricky. If we multiplied every number by, okay, if we do mod division here, if it's above 10 and you mod it by 10, I'm just going to create a new cell to show you what I'm thinking about. 10 mod, or like we get 15 mod 10, that's going to be 1. Oh, that's the remainder. I want floor division then. Okay, floor division works. 25 mod 10 will be 2. 5 mod 10 is 0. Okay, we can use this to our advantage. So our new group will be the values in A mod 10, and look at this. Look at DF. Okay, we got a group now, and now we basically can, map these groups. This group's right here to a value. This is kind of ugly, but what we could do is a dictionary for loop type thing. This I to this value for I in range. Let's see what groups looks like. Cool. Oh. You just do it like this. Perfect. All right, we finally got something here. So dfa is this, and then dfa is going to be equal to the replacement. I think we can map. Is this a dictionary? Groups. Hear me out. And then finally, we can do a df dot group by A and then we want to sum. Take B and sum it. Something like this. Look at that. Heck yeah. Oh man, that was kind of difficult, but we got it. Good work. The key here was this floor division to help us do what we needed to do. But we do see 635, 360. 635, oh what? Oh no. This should be to 20. Oh, okay. One sec, one sec. So that we do want this by 10. This is now divided by 10. Groups look right here. Why did this math not work? 10 to 20. 635 is correct. I feel like we're very close. So if it's what happens if it is exactly 10? If it's exactly 10, then dividing it should be the 1. But we want 10 to be inclusive here. So I guess this should be DFA minus 1 divided by 10. Nope, that's weird. Okay, trust me, this is going to work. We want it to be, because if it's 10, it should be in the first group, but 10 floor divided by 10 is 1, but 10 minus 1 is 9. 9 mod 10 is 0, so this would be in the first group. So we're just offsetting it 1 to account for the index. Run this. 635, 360, 315, 306, 750, 284. Cool, we got it. All right, that was a little tricky, but looks good. All right, I think that's a good point to pause and look at the solutions quick. All right, we were at 27. Oh, there's an n largest function. See, we're learning a lot. What does this level do? I'm going to look up what level does in df sum. Okay, it looks like this is probably the better solution robustly, but this was an equivalent back with older versions of Python, so that's what the level is doing. It's basically group buying. And largest, that's helpful to know. Let's see this next answer. Oh, wow. pd.cut. What does cut do? Oh no, I don't want this. Let's look up pd.cut. Use cut when you need to segment and sort data values into bins. This function is also useful. X is the value to be cut, so that's probably DFA in our situation. Bins is the range. Okay, this makes sense. So let's see how it looks. Yeah, you're cutting A, and you're doing it with 0 to 10, 0 to 101, split by every 10. Then you're grabbing B, and you're summing that. Cool. This is just a more elegant way to do what we did. All right, let's keep going. DataFrames, harder problems. Oh no, harder problems? Oh, okay, so we're getting into the hardest. I guess it will get easier again, hopefully, with the series and DatetimeIndex stuff. But these are getting pretty dang hard. All right. Okay, that's interesting. The difference back to the previous 0. So we'll grab this data frame. Okay. I feel like maybe this could be done with, I mean, I know of like non-pandas ways to do this. You could just basically find the indices of each 0 and then do some sort of back calculation. But that would probably require 2 loops. I think we should do this in one single pandas command, ideally. So like one thing I immediately think of is like df dot, you could do like df x equals 0, and we would like get the indices here. Which is 2 and 7. And then we could use that in this. It would be like an equivalent type problem that we could think about here. I'm also like thinking of some sort of like multiplication and addition type thing where you're like, df 0 equals df x. You could do something smart here where you take the cumulative count and Like I'm thinking just like cumulative product would always get you back to 0, which is good. And then the cumulative count between those zeros. The cumulative product would always be 0, I guess. Could we go like back and forth, like one way backwards, one way forward? All right, let's just solve a, like what would be a dumb solution? Dumb solution might be what we were kind of doing before, where we got the indexes. Got those indexes, and then we could do something like dfy equals df.index, and then it subtract these and take the max. Like zeros equals this. We would want to take the min. We don't want to take the max. We'd want to take the min non-zero value, or non-negative value, or zeros. This is definitely not the most Pythonic here. Okay, this gives us the index. We could one thing that I'm thinking of now is basically filling. You have 2, 7. So I basically would want to fill like zero, 1, 2, 3, 4, 5, 6, 7. Like basically create an array of this size that looks like this, that's the zeros filled until the next 0. So it always tells you the index of the most recent 0. What that looks like, though, I'm not sure in Pandas syntax. Is there a NumPy way we can do this? Let's try to use Copilot to our advantage. Given a list of indices such as 2, 7, and a length such as 10, create an array that fills index positions with values until the next value is reached. For example, 0, 0, 2, 2, 2, 2. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 items in Python. Let's see what happens if we do this. Is there a nice command to do this? Oh, interesting. NP repeat. What does values look like? So we just need to fill this basically with zeros. So I think what we could do is if this was 0, 2, 7, would this be correct? I think it will be. Perfect. Oh, I don't know if I need the result here. I think we can just use values. Yeah, values works. Now instead of this, our zeros equals our indices now is this plus the 0 index. Maybe we use the 0 one first. Our length is the length of our data frame. And then basically, we want to do like a difference minus indices. What does DFY look like now? Well, I think we're off by 1. It's right everything but the first 2. How could I make the first 2 proper? Try to do 0 minus. Honestly, I could make this a -1 and it's going to work. Maybe not. Why does this not work? 0 works. But -1 doesn't. I don't understand why -1 wouldn't work here. Let's print values again. I could do something like this. This would now fix everything. I don't like that. Why wouldn't it let me do a -1 here? Maybe if I made this all NumPy or something. Oh, maybe because this is not then indices if it's -1. It gets thrown off because it tries to go to the end of the list. That would make sense. This kind of works. It's not like terrible, but it's not the most elegant. How would we improve this? I don't know. I'm happy enough with this. Let's see the solution for 29. Okay. It's not an elegant solution that they have either, so I'm not too worried about our solution, I guess. This is just a tricky problem. Oh man, this is just ugly. But there's some good solutions here. Interesting. All right, let's try problem 30. Consider the data frame constructed below, which contains rows and columns of numerical data. Create a list of the column row index locations of the 3 largest values in this data frame. All right, what's a Pythonic Pandas way to do this? We're gonna, to get the largest solution, we need to look through every value no matter what. So for me, it seems like we should reformat this to be like a series and then just keep track of the largest values in the series. How can we flatten this? Is there like a flatten command? df.shape, is there? How could we reformat this? 8 by 8. Can we reshape? What if I did like 64 by 1? What happens there? There must be some sort of reshape. Reshape data frame pandas. I don't know if pivot table is exactly what we want. There's .values.reshape. We can try that. .values.reshape. What happens if I do this? What happens if I just do 64? Okay, that kind of works. But now I need to know their corresponding indices. I could be smart and just kind of know that every 8 I go, or every initial shape I go. Okay, I kind of like this approach. We need to know the original shape. So shape equals df.shape. We're going to reshape to be, ultimately this is shape 0 times shape 1. It's the 2 values in the shape. So if I run this, you'll see we get the same answer here. Okay. And then basically, we want to find the indices of the max. Indices equals, what happens if I issue is that this is no longer a data frame. If I did something like df_new equals pd.dataframe values. Now we have indexes mapped to these values. We could do n largest. That not work? I mean, this is not the best way to do it either, because I'm creating a data frame. I feel like that's a slow operation. It's so tricky because it's like one thing to do this, it's another thing to like do it the way that they're anticipating. But then basically our final output is we take the indices of this, and then we basically just need to convert this into this format. And we can do that. I guess one way we could do this is like, this is equal to width, height. And this is width times height. And then basically our final output is output equals x mod height comma x, or x floor divided by height gives us one thing. Then we need to know like the leftovers. Now, our height will be this divided by width, then x mod width for x in indices. Five, 2, okay, close, I feel like. This is the remainder. 6, 7, 5. This is close. 2, 5, 6, 4, 5, 7. That works. The exact details here, basically, we're converting an indice that is a straight value to a like row value or row height type value, and we can just do that with some smart addition. Oh wow, did I? I feel like this should be width. How did this get to be the right answer? Ouch. I don't know if this width height, the issue here is this is a square in this one. I would have to play around with it a bit more to know if I'm actually calculating the width and height correctly here. Looks like I had it backwards, so it was height comma width. This would give us something seems a little bit off here, but I'm fine with this answer. We can go see what the solution is. I'm just getting a little caught up in the details of width and height and like what the order is. I mean, maybe let's look back at our original. Two, 5 was one of them, 96. So that's kind of depends on how this gets reshaped too. I don't know, I'm okay with this. There's something a little bit off here, but hopefully my thought process kind of made sense. View, appearance. What problem was that, 30? Unstack. Okay, that's basically what I wanted, but I couldn't figure out how to do it. Let's see what this the unstack function does. Yeah, because if we look at our solution, we reshaped. This is the equivalent of unstacking. And then we took the n largest, once we created a new data frame, which is like the equivalent of their sort, and then did a little bit of getting it back to normal. Their solution, sorted values, this is ascending order, so -3 onward gets the last 3, takes the index. I'm interested by, I'm going to run this. Oh, I guess, I don't know if I can run this, because I don't. Import pandas as PD, import numpy as np. Let's look up how unstack works. Oh, this must do that nice operation automatically. That's cool. Unstack Python. What is the default level? Default -1. Okay. So just to give you a sense of what this is doing, create a new cell above, copy this in real quick. If I call unstack on this, it's going to create a multi-level index. And then if I call index on this, we'll get the, 0, 0, 0, 1, all of this. And then it just makes it easier to get what you need to with that. Cool. Unstack is useful to know. All right, let's try one more. Dang, we're still at the hard ones. Jeez. You're given a data frame below with a column of group IDs, groups, and a column of corresponding integer values, vals. Which contains the same values as the vals, any negative values. Okay, so just if it's negative, it becomes the group mean. If it's positive, then it stays what it is. Copy this. All right. So patched vals. Is there an easy like if-then operator? So we basically want to have two conditions. It's like called a ternary operator. Ternary, is that 3? Binary? Ternary operator pandas. Okay, we can use np-where probably here. So df patched vals is going to be equal to an np.where if it is our condition. I think the first thing is the condition. Hopefully the np-where pops up. The condition, so that's going to be, how do they do it with that example? Okay, cool. np-where less than 0. We want, if it's true, then we want the group mean here. So PD, this is tricky with the groups. It's easy if there's no groups. The groups is kind of throwing this off. Is there like 2 np-wheres? Like I can imagine doing pd.groups here equals a. That's not great though. Works when there's 2 groups. This wouldn't scale if there was multiple groups. But if that's true, then it would be pd. Or b. That's so confusing that they're using PD here. It should be df groups equals a. And we want df dot group by real quick. Group by groups dot sum dot mean, then loc a. What would this give us? I feel like the group mean is often going to be negative. Okay, now we can finally do patch values equals, it's going to be a mean, comma b mean, and then we'll do one more of these operations, which will be df patched vals vals, which will be np.where df vals is less than 0. We want to, if it's less than 0, we want to do what it already is. But if it's not, then we just want to do df vals. Now we look at df. I think that that's correct. I feel like this is not worded properly where it wanted only the positive values, not negative values here, because this should be, because they're setting this random state, this will be always the same, so we should get the same as them. So I feel like what this actually is like df.vals greater than 0, and then that. Yeah, it just didn't specify that in the question, but we do see that we get the same answer now. So np-where is a useful function to know about. All right, 32, implementing a rolling mean over groups with window size 3, which ignores not a number values. This is crazy. It's like, it's like we need like a duplicative data frame here. df equals this. Okay, we got that. Like, we're rolling over this. As we do that, can we like group by with rolling? Oh man. Window equals 3. How can we ignore if NaN? I don't know. I might retire at this question. I'm just going to see how this solution looks. What is min periods? Okay, minimum number of observations in a window. That's useful to know. So min period's 1. Lets you get a value even if there's NP, NaNs in that. And this just gives us the count of how many values that we're looking at. It's pretty wild question. Whew! All right, but we're now to series and DatetimeIndex. I think this is a good stopping point. All right. Let's keep it rolling. We're back to some easy/medium problems on series and DatetimeIndex. Create a DatetimeIndex that contains each business day of 2015. Is there a data frame that I get to use for this? All right, let's import datetime. Or import datetime as datetime will do. Oh, do I actually want to do from datetime import datetime, I think? From datetime import datetime. Then we want to do datetime dot year 2015. All right, for this first one, I'm just going to Google this. Get each day in 2015 Python datetime. Cool. You can use this. Type of thing that, yeah, you're not necessarily going to know off the top of your head. PD or business days equals 2015 to 2015, 12/31. Let's see what we get here. Okay, so we see that like it's missing the 3rd and 4th of January there, so you can assume those are weekend days. And we want to use it as to index a series of random numbers. So the series will be called S. S equals pd.series index np.random dot is there randints? I mean, I'm going to just look above and see how random numbers were generated before. Randint, that looks good. randint. Does it automatically give us a s equals np.randint what the heck? Oh, np.random.randint. Equals length business days. Then we can finally do pd.series s and index equals business days. Look at that, we got it. 261 business days, that sounds about right. Okay, find the sum of the values in S for every Wednesday. All right, values.index, what does that give us? Okay, and then we can do date. Date, does it work? Okay, .dt, or I think we can do .dt. Okay, I guess not. .date, .day. I guess we could do day of the week here. Okay, perfect. Day name. And then basically we want to filter if day is equal to Wednesday. So I think we could do something like values.
Type thing in there. Yeah, so it wouldn't fit into my home.
All right, so we could get the indices of Wednesdays here. So we got values dot index dot date equals, or what was it? Day name equals Wednesday. Who cares what this will give us? We're going to do .loc. Pandas filter series by index, by condition on series index. Okay, we got our values. Let's think. We have, if we look at the type of values, oh, not types, type of values. Oh, and then we specifically look at the type of the index. We see it's DatetimeIndex. So that gives us some useful functionality, such as like index dot values.index.dayname is one useful thing here. Call that as a function. Okay, so we could make a new column, values day equals this, or equals this. Let's see what happens if we do that. And then what we could do is values dot day equals Wednesday, and then do a dot sum. How does the index object not have? That's weird. That works. What's up with this? That's oh, we can call this series S. Call this values. Call this S. Cool. All right, find the sum of values in S for every Wednesday. s.index equals this. I kind of want to make this equal the index. And then we can make some new columns. I'll call this day of week. That's going to equal s.date dot date what type of column is date? PD dot toDateTime. I'm not used to the index being the date time. I feel like I'm used to it being in a column. So S looks like this. S dot type s.index. See, it's a datetime index. Let's look up Pandas datetime index. Oh, can we just do day? Oh, okay, here we go. This is helpful. Day of week. Monday equals 0. Sunday equals 6. So Monday is 0, then Wednesday would be, should we set the index? S equals s.index.day of week. S day equals Monday is 0, Tuesday is 1, Wednesday is 2, equals 2, and dot sum. Datetime index pandas series filter by day. All right, so we have s.index, and if we do the type of this, we see that it's a datetime index. The thing that I get confused about though is I'm not used to filtering by index specifically. I'm used to having this be a column. So I'm going to just quickly check the answer to this first one because I think based on how they do that, it'll probably inform these next ones. s.s.index weekday equals 2 dot sum. Oh, because it's a series, we can just do something like this, it looks like. I was thinking we'd have to grab the column name, but looks good. All right, so s. Then we can do s. Then we want to filter s.index.day. We have some functions here. Day of week is 1. If we look at the documentation for day of week, we see that Monday equals 0, Sunday equals 6, so 1, 2 would be Wednesday. Equals 2. You could even do something like Wednesday equals 2, and then you could set this to equal Wednesday. And then we can just call dot sum on this, I believe. Cool, we get that. What we're going to see, though, is if I run this again, it's going to give us a different value. Oh, I guess maybe the random state is staying. I thought we'd get a different value here. Cool, I guess it's still using a random state from some of these above examples. Probably random state 31. I bet you if I did mp.random random state of 35, I bet you this would change the answer. What the heck? Oh, oops. Should be values. Yep, that gives us a different answer. Running this again will give us the same answer. Okay. I'm going to get rid of this random state, though. Cool. Right, for each calendar month in S, find the mean of values. So in this case, we could do s.index.month. Is that a s.index.month name or month? Let's see what month looks like with our date index. Where's month? January equals 1, December equals 12. Oh, so it actually wants us to not just grab this wants to do a group here. s.group by s.index.month, I believe, and then do a mean. I think we can do this. Cool, so that's January, February, March, April. That works. Cool. For each group of 4 consecutive calendar months, find the date on which the highest value occurred. Okay. So in this case, we want to look at a rolling window of 4 calendar months. So we basically want to do s dot rolling window equals 4
but that's specifically on we specifically want this on the month. So I feel like we got to do s.index.month. I don't know if this is going to work. And then we basically want like the index max. Will this work? How can we look at 4 months at a time? Maybe we group by month first. What does this give us? Rolling window equals 4. Then index max. Can I do this? Rolling group by has no. I feel like this is kind of close. The issue here is I need like a subindex. I'll look up a solution of this one. I'm going to look up pd.grouper real quick. Quite useful stuff. Cool. Oh, let's go back to problems. All right, 37. Create a datetime index consisting of the third Thursday in each month for the years 2015 and 2016. Okay, so we can start by doing values, or I'll say dates equals pd.date range 2015 01 12 31. We'll start with that. Okay, that looks good. Index. So we want to do dates. Dates dot day of week equals 3. But we also want it to be the third one. So I feel like we need to do a dates filtered by dates dot group by dates dot month. Then I think we want to do dot day dot group by. Does this work? By the month, and then we want to do the third instance. Okay, let's see what this gives us. Maybe we want to start by doing a dates.group by dates.month. That looks helpful. Then basically for each of those, we want to grab the day of the week equals 3. Then grab every third. Oh man, this is tough. Going crazy. Let's go to the DatetimeIndex reference. I'm going to look at the solution for this one too. Oh my gosh, you can use this frequency stuff here. So this would be, we need to learn about this frequency syntax. Weekly frequency. Is there OM here? Week of month, third Thursday. WOM. Create a date. X day and Y week. This is something that we'll have to play around a bit more with. I don't fully grasp this. Cool, we'll pause these exercises here. All right, let's keep going through it. Let's do some cleaning data. This is a fun data frame. Okay, let's get the data frame. All right, I'll make this cell one below. All right, these numbers are meant to increase by 10 with each row, so okay. Modify df to fill in these missing values to make the column an integer column. Okay. This is tricky to do robustly. Like, it's easy enough for this simple example. df like what we could do is df flight number equals np dot a range. Then we can do this. Now if we look at df, we see we get the correct values. This is a decent solution if they're ordered. You know that you could fill them in properly. Like, I didn't like doing, like, if we load this in again, and maybe I will do this on here just so we can always see how things are evolving. I didn't love the idea of doing a fill NA because, like, yes, I could technically have done this, but I just feel like this is not the most robust solution. Or, like, yeah, I guess you could do single values. This is not great because then it just fills it the same. So I liked the idea of doing a range starting at the first value, going to the last value, and because this is exclusive, this last value, we need to make it like 86 or something, and then going up by 10. That looks good. And if we look at the type now, df_info, it should be an integer column. Yeah, we see int64. That looks good. That. Okay, the from to column would be better to separate columns. Split each string on the underscore delimiter to give a new temporary data frame called temp with the correct values. Temp. Okay. From to. Okay, so what we want to do is do something like temp, I guess, equals df. Yeah, I guess df.copy. Then we could do temp. We want to set, make a from column and a to column. And we'll set that equal to temp dot index on from to dot string dot split on the underscore. I think this will do what we want. Then we'll want to look at temp dot head. Columns must be the same length as key. What happens if I just call this split method? That looks right. Now I just basically want to set that. Do I have to do temp.loc? Like if I did, oh, does it need to be like this? That might be it. Or like pd.series temp from to I'm going to try this. It wouldn't be a series, it would be DataFrame. Maybe that's the issue. That's so weird. All right, this is a good use case for Copilot. Columns based off of the split of an original column in Pandas. Oh, expand equals true, I guess is the keyword we were looking for. But it was very similar to what we almost had. Expand equals true, useful to know. Then we can do temp.drop columns equals from to. And finally, let's look up at our temp. Oh. Cool, that looks good. Okay, for from and to, we want to do temp. I think we can do from to equals temp from to dot string capitalize. I might have to do this one at a time. Like it'd be very easy to do. This. Copy that. And do it for to as well. And then we'll see what temp is after this. Yeah, that looks much better. I wonder how you do it in one single line. Let's see. Make this a single line that does the same thing. Oh, it looks like we could apply lambda x dot string dot capitalize. That might have been the play. Good to know. Delete the from to column from df and attach a temporary data frame temp from the previous questions. Did temp just have... Oh, we did more steps probably than we needed to. So what we could do is do df dot join merge, or I guess we could do df equals pd dot merge df right equals temp how equals, we want to keep everything on the left. I think it doesn't really matter because they'll have the same flight numbers. Just going to leave this without a how. Do on equals flight number. Let's see what, we'll call this DFA temporarily, just because I want to make sure this is correct. All right, that I think looks good, and then we can delete the from to. df equals this, df dot equals df dot drop columns and then let's look at df. That looks pretty good to me. In the airline column, you can see some extra punctuation and symbols have appeared around the airline names. Just the airline name. All right, so we just want letters here. So I feel like one thing I'm thinking about is regular expressions to just get the text. df oops, I should probably drop. I think if I did how equals left, maybe. I don't want to keep the columns have the same name. Let's just look real quick. How to drop columns that are duplicates in pandas. On merge. Okay, we can do something like this. I'm going to just manually, I think, drop them. All right, let's run this again. That work? Cool, that looks good. We just more similarly copied this. Perfect. Okay, df airline is going to be equal to I'm just going to make a copy here, just so we have our original data frame. A equals df.copy. A airline equals a airline dot string dot, what do we have for string functions? Can we replace? I'm trying to think without Googling it. What's the best way? I could like strip all punctuation. Seems like a prime Google thing. Pandas remove punctuation from column. From string column. Perfect. Yeah, regex works. And this is saying not a word character and not a space. One or more, replace that with nothing. This makes a lot of sense. And now if we look at A, you got to do regex equals true. Did they require that in this? It did work once we did regex equals true. Oh, interesting. The 12 is still here. How could we get rid of the 12s? We don't want numbers, so not word, not, what is numeric in? Not digit. I think this would work. Numbers in regex. Shorthand /d. That's what we did, right? What if I did 0 to 9? That's so weird. Oh, wait. I'm saying not number. So how can we do specifically letters? I think we could do not A through Z, A through Z, or space plus. There we go. Nice. So the word /W included numbers. This doesn't. In our regex replace. That looks good. And now we can actually just do that on DF. Cool. In recent delays column, the values have been entered in the data frame as a list. We would like each first value to in its own column, each second value in its own column, and so on. Is there expand, explode? Maybe explode does what we want. All right, transform each element of a list like to a row. Oh no, this is gonna explode it downwards. Can we? So this basically would make 0 have 1 have 23 as recent delays, and then another 0 or another index have 47. So that would explode it like the wrong way. Expanding maybe? Explode into columns, new columns, pandas. There we go. Dynamically expand lists Python pandas into columns. Let's explode. Oh, okay, so we just need to do the max here. So we can start by looking at df. We're going to get length of longest list in a column pandas. Let's see what this does. This should give us 3. It does. So our columns will be new columns equals delay underscore I. Make this an F string. For I in max length. You could even do this as part of the same call if you wanted to. I in range. I kind of like doing it as a separate. I in range 1, 2 max length. So it'd be 3 is the max length. We want this to have delay 1, delay 2, and delay 3. So this would be max length plus 1. So those are our new columns. So our new data frame would be delays equals the data is going to be pd.dataframe, and that is going to be df dot recent delays columns equals the new columns. And now what does delays look like? Okay, nothing is being filled in. Can I just do dot values here? How can I fill that with take recent delays column and create new data frame with each value in the list value in the list as a new column in a new data frame. Data frame. The column a value corresponds to should be the index it is in the original list. Fill NaNs for values that don't have the same number of elements in original list. Let's see if this works. Wow. You can just do dot apply PD series. This is so simple. But we wanted to do probably, I mean, we could just do delays columns equals new columns. Watch this. And then delays. That looks pretty good. And then we want to replace, we want to add delays to our original data frame. So we could just do df dot, or pd, df equals pd dot merge df, and then delays, and then left equals left. What does left index and right index do? Like, this is going to work. I just don't know exactly why it works exactly how it should. If we go to new cell and look at df, oh, and then we want to drop. Df equals df dot drop columns equal recent delays. df dot head. Looks good to me. Okay, to warm up, we'll make a series with 2 index levels. S equals pd dot series index equals I think we could do a I think we can do letters equals A, B, C. I think one cool thing about this video in general is that I'm learning where my weaknesses are. Like multi-index is not something I'm super comfortable with, so I'm learning that maybe it's something I should become more comfortable with. It really kind of depends on what you need to work on. I'm just going to say 1. Letters, numbers. There's 2 indexes. S. Create a multi-index series of random numbers using letters and numbers as indices from above. Cool, that looks good. Cheated a bit, but hey. Curious what the solution here is though. Let's look at the solution real quick. Here's some of these other solutions too. Oh, interpolate. That would have been a great function to use. That would be much better than the solution we ultimately did. Wow, that's a good one to know. Temp, cool. Okay, that makes sense. All right. This is pretty similar to how we did it. They did it in 2 lines. df.join, okay. df.join instead of merge would have been probably better. String.extract, okay, so we did regex replace. They extracted just the letters, so another good one to know. Okay, this doesn't use the F strings, which is actually a better format, but this code is a little bit old, so that's probably why it doesn't. Yeah, this is interesting. Okay, multi-index. Okay, that's how you do it. Cool. All right, let's keep working on our tasks. Lexicographically sorted. This means alphabetically A, B, C. Looks good to me. It's not A, C, B. So that is correct. Select the labels 1, 3, and 6 from the second level of the multi-index series. So that's going to be s.loc. Basically, I think we want to get everything here, and then we want to just get 1, 3, 6 from the second level. I think that this will work. I'm so unfamiliar with working with multi-index. I think you could do something like this. This is my, okay, that worked. I just had one extra brackets before. Might have also been able to do something like where you actually specify the level when you're using loc. I'm not positive. Slice the series S, slice up to label B for the first level, and label 5 onwards for the second level. So this would be like s.loc. I think we could do something like 2b for the first one. I don't know if this syntax works. It'll be interesting to see. And then 5 onwards for the second would be something like this. Wow, that's kind of cool. Up to B, includes B but doesn't include C. That's cool. This is why it must have to be lexicographically sorted. So yeah. This is what this is really saying is A to B, and this is saying 5 to the last index or whatever. But the shorthand is you can just remove those, and it knows to start at the beginning. Sum the values in S for each label in the first level. Ooh, this is interesting. Stat. S, everything. Can we do like a s.group by first level? I don't know how these levels work. And then some or something like that? I don't know. Oh my gosh. That's wild. I think we got it to work. So I bet you this would break if we try to do 1. Okay, this is summing the values for all A's for these levels. Okay, that's cool. So level 0 is the first index. And if we look at our original S, we see 15, 64. I think a good example is we could just look at 15, 31, it's 46, plus 78. 46 plus 78 is 124. So when we do level 2 here, or level 1, we should get 124 for the first one. We do. So this is just basically defining what group we sort by, and then it's summing. That looks good. Ooh. This is basically giving us a hint on how we could probably do a pivot table here, or what was that other function that we saw earlier in the video? Unstack, right? What does unstack do? Let's do s.unstack. What is that going to give us? Ooh, I like this. I like this. And then we want to sum by axes equals 1. I always forget the axes. Let's see. Let's see the documentation. Let's try to actually read this. Index. Axes for the function to be applied on. We want it to be applied on the columns, so it's going to be 1. Or no, we want it applied on the index, so we can leave it blank. Nope, I guess not. By applying it on the columns, applying it on the index, you keep the columns and you add the indices. So we want to apply it on the columns. Okay, 380. Cool, look at that, it works. So this unstack has come useful. You could also probably have done a pivot table here with S. We have S. We could have done s.pivot. Does s.pivot table work? I don't know if this will work for a series, so I think unstack was the play. We can check the solutions real quick. Test, test. Oh, wow, this is a nice little function. Looks like how we did it. Not quite how we did it, but we were able to actually just do it without this index slice thing. Sum level 0. Same thing with the group by level 0. Unstack, look at that. Oh no, we're going to see the solution. I feel like their axis was off in the solutions. Maybe I'm wrong, but I think it should be axis equals 1. Keep going, 50. Oh, interesting. Isn't that what we already had? I think it meant numbers, letters. Can we like unstack and then unstack again? Wild that this worked. Oh man, is there a way to do this without doing this? Basically leverage this command twice. Now if we look at, let's call this ss equals, if we look at ss.index, we see numbers, letters, cool. And I just remember seeing the examples on the unstack that there was some weird stuff you could do. So that's what made me think that this was a possibility. If I just called unstack, unstack, it would have gave me the original. There's probably a better way to do this, though. Oh, swap level. That would have been a nice way to do it. Let's see what that gives us. What does this look like? Curious what the actual docs say for swap level. I think I could have just done this, right? Yeah, that would have been the same thing. Okay, worth looking at the docs, but I think we can move on this one. All right, Minesweeper. Generate the numbers for safe squares in a Minesweeper grid. Check this out if you haven't played Minesweeper before. Okay. Okay. 3. This is always 0. Trying to think what this would expand out to be. Two columns, x and y, containing every coordinate for this grid. I feel like we can do this with NumPy. np dot let's make it size x equals 5, y equals 4. Basically, I want to create a matrix of this size and then get the indices matrix from that matrix. I'm going to do this. I'm going to do something like np.ones, how about? Because I know that that will create a matrix of x, y. I'll just call this ones equals this. And if we look at ones, look at that. And I bet you we can do dot index or dot like indices. Is that? I'm going to do a little copilot here. Get all indices from 2D, is this 2D? I guess 3D array, NumPy array called ones. Okay, there's an np.indices. Let's see what indices looks like. I don't know what the transpose is doing here. I don't think I need this. I think I can just do this. That's weird. This should be all two-dimensional. Can I do something like this? Will this give me what I'm looking for? Let's just think what this would actually expand out to be. We have 0, 0, 0, 0, 0, 1, 2. Oh, this is weird. Okay, never mind. I'm overthinking this. This only is ever going to have two columns. So if it's, there's basically two loops going on here. Basically, it could be done with 2 for loops. So if there's 5 x positions and 4 y's, it would be 0, 0, 0, 1, 0, 2, 0, 3. And then we get to 0, 4. No, 0, 3, that'd be it. Let's think. That's all the x positions for the y position. It's all the y positions for x equals 1. Then it would be, okay, this, we'd repeat, 3, okay, and then finally 2, 0, 2, 1, etc. Okay, so how would we generate this? We're going to use this as reference. So for our x values, we want it to be x equals np dot array it's like np dot, I don't remember the difference between range and a range. We would want basically 0 to x. And then I feel like we want to do like x equals x dot or np dot repeat x like y times, something like this. Let's print x and print x new, and it'll print x. Okay, we can comment this out so it doesn't interfere. And get rid of this stuff. Run. Oh, wow, let's go. That repeat worked. Cool. Awesome. That's exciting. I just vaguely thought that could work, just from seeing the repeat in, I don't know, some of the other examples above, and I think solutions or something. Cool, that works for x. And now how can we do, and you could even like put this inside of this. Honestly, so basically, if you wanted this in one line, it'd be this. And if we run this again, we get exactly what we're looking for. Now, what is y? Y is equal to, I think we can basically flip this. Or I think we could just do np.arange. We want to do 0 to, oh, and I guess I didn't even need to do 0 to x. We could have just done x, I think, here. This could just be x, and I bet you we'll get the same value. Yep, we still get the same value. This other one would be y would be equal to np.arange y, because it just goes 0, 1, 2, 3. And we want to just multiply that by x. I believe that will give us what we're looking for. Print, because this just basically says repeat the numpy array x times. So print y. Nope, I guess not. Maybe I can do this. Not quite. Is there like an axes or something thing in this? Doesn't work like that. Repeat full array, not individual values in array. I guess tile is the command we're looking for. Let's now try this. That looks right. Okay, perfect. So now our final data frame would be data frame x comma y. Our columns are equal to x comma y. And I should probably move this below where things are defined. We can remove this. How can we just join these together? I think we could, I guess, zip xy. Does this work? Can I see what this is? I think it's zipped. So zip, basically we want to take the 0th index in this, 0th index in this, pair them together, then go to the next index, pair them together. And I think it's zip. Show values in zipped NumPy list. Let's see what happens here. Yeah, this looks right. So I think zip xy is right. Can we make a data frame out of this? pd.dataframe zip xy columns equals x comma y. There's probably maybe a better way to do this. Zip is super useful. df equals this. df. Look at that, we got it. Nice. Zip is a good one to know about. Good function to know about. You can like unzip things too, which is helpful. And you do that by like doing a thing, zip star x star y or something like that. Or forget exactly, but there's ways to unzip. Cool. Okay. Now we have df zeros is going to be okay, what should we call this? I don't know, mines. And that's going to be np.where np.random is less than 0.4. Random will generate a number between 0 and 1. So probability of 0.4 would be less than 4. So if this generates 0.1, then the probability that it's less than 0.4 is exactly 0.4, because that's how much of the space it fills. And if that's true, then it should be a 1. If it's false, it should be a 0. That's our mines, and let's look at our data frame now. Apparently it didn't work. Do I have to do this? That looks good. Let's just look up real quick np.random.random. If I do 10, okay, so yeah, I had to pass in the size. And you could do a random state to keep this always the same, because right now if I generate this multiple times, we're going to get different values for our mines. Oh wow, now create a new column for this data frame called adjacent. This column should contain the number of mines found on adjacent squares in the grid. Okay, adjacent will happen if any of the numbers is ever one off from the other values, G's. So like 0, 0, the adjacent would be 0, 1, 1, 0, and 1, 1. Oh, that's tricky. I think that there's probably some sort of like cumulative sum moving in multiple directions, but that's not easy to think about. df adjacent is going to be equal to
it's like a window function. One going downwards. I feel like what's going to be helpful is to not have it this way and to actually expand it into more of the actual matrix look. How would we do that? I think pivot table here. Would that work? This is tricky. Adjacent squares in the grid. So like, do we make these the indices? Was the multi-index stuff a warm-up for this? I feel like it is. Maybe I'm wrong. Like, I feel like I'm breaking this down into 3 cases. Like, you have horizontal adjacents, we have vertical adjacents, and diagonal adjacents. So like to calculate the horizontal, we would do df.groupBy. We'd want to be on a single y value, so we would do group by y, then like sum. I think that would give you the number of mines in that row. That just kind of confirmed that. So y equals 0, there should be 3 mines. Y equals 0, there's 1 mine. Y equals 0, there's 2 mines. Y equals 0, 3 mines. Okay, that looks good.
So that'd be like the total mines on a row, but how would we, you could do like cumulative sum to get number of mines you've seen up to that point on the row. What about cumulative count? Window size should be 2. Min periods should be 1 because no. I feel like this is close-ish. Like, so a lot of these problems, I feel like I've said this a couple times, but like it's easy enough to do if you use loops and stuff, but very much trying to stick to very Pandas-specific methods that are much more efficient. So that's where I'm getting tripped up. We could use padding. I feel like padding would help. It would simplify things. So if we look up our data frame, I do like pivot tabling this. Our columns are going to be columns equals x index equals y values equals mines. Okay, this is much easier to read grid. And then if we call this new grid and we do new grid equals that, new grid, I think there's a dot padding. There's pd dot pad. Add padding to data frame of size 1. Fill with zeros. So I'm thinking about the logic here. That's not exactly what we want. Add padding to DataFrame, new grid, so that it has zeros above and below the actual values. Let's see what happens here. New grid. Cool. I feel like x should be -1 as well. That fixed the y. I think I can do this all with like a window function. New grid. Okay. Now you want to I need to see both at the same time. Okay. That has 1 adjacent. Okay, that looks good. This should have 1 adjacent. It does. That has 2 adjacent. This should have 3 adjacent. 0. Or maybe the window size should be 3. You should not count yourself. You want to mask yourself. All right, I'm going to just do a dumb solution. I'm just going to show how I would do this non-pandas specific. I do something like for row comma index, or is it index comma row in df dot iter rows. print index, print row. Okay. And what I'd basically do I would set this as a new df equals, do the multi-index stuff. Given columns X and Y in a data frame, make X and Y the new index, new multi-index of df. Okay, and then we basically would want to go print index. What is the index here? Okay, for this index, we want to get the adjacent ones. So new df going to be dot loc of the current index get count equals zero. Basically, we're going to look at all the different positions that could happen here. Ideally, we could pad the data frame so like none of these would be non-existent. But just to show for the first example, x plus 1, x plus 1, y plus 1, and then x, y plus 1. Basically, each one of these, we could do count plus equals, count plus equals, count plus equals. So it's if it's a mine or not. And then we print count. And I just want to do this for the first index, so I'm going to break. Mine's 1. So let's look back at our data frame. df.pivot table. Columns equals x, index equals y. And values equals mines. Okay, so 4, 0, 0, we should get 1. We do get 1. What if we were to continue this? The next index, so if we look at our indices, make this a new cell. New df.index. We get all of this. So if we're iterating over this index, down below, we get this. So the next one we're going to do is 0, 1. Y is 1. So it should be this one. That also has 1 nearby. So basically you can repeat this for, there's going to always be up to 3, 4, 5, 6, 7, 8. 8 nearby. So you have to do the 8 different cases here. Just not very Pythonic. It just must be a better way. And if we ran this all the way, I feel like it's going to break because it's going to get out of the index. Yeah. Runs up. So there's just a bunch of conditions you need to worry about. Oh, I guess each time we should be doing specifically mines. This is just getting really ugly, and I'm kind of losing my mind a little bit, but we're chilling. This is like a fun problem. I'm just getting a little tired. I might look at the solution here. This is pretty neat looking. I'm fine with our solution here. Scroll down. Get out of here. Dang, computer's frozen. No. Holy moly.
Oh man, this is a brutal solution. Oh, convolution. That is really smart. Oh man, I like that a lot. Oh, I like that a lot. Should have gone to computer vision land. That's smart. This is a smart solution. I'm trying to think how this works. I really like the solution that they share. Worth checking this out. Convolutions basically, let's say you had your grid. You basically make a grid around the grid and you just move the convolution everywhere and basically add the values that way. That's kind of like in my head what I wanted to do, but I didn't know how to actually do it in Pandas land. All right, let's go to all right, Minesweeper, I'm going crazy. Gonna call it there. All right, let's do 56 onwards. Which is some plotting stuff. Cool, cool.
And they give us a link to documentation, so probably worth loading that in as well. I don't know if there's a question here. I'll make a scatter plot of this random data, but use black X's instead of the default markers. Okay, so let's import this. One neat thing you can do in any sort of notebook if you don't have a library installed, which I don't know why this current Python version I'm using doesn't have pip, or doesn't have matplotlib, but pip install matplotlib should install it. So the exclamation point syntax lets you type in terminal commands. Okay, let's see what we got here. It's all runs now, nice. And now we need to create a scatter plot. So we'll copy this code too. I don't know if it's saying the x's should correspond to the y's. That's kind of how I understand it. Oh, I think it will, because it's passing this in as a data frame. So if we look at this and then do df.head, we'll see a nicer looking view. And then I think we can just do df.scatter, or df.plot.scatter, and our x's will be x's and our y's will be y's. Did that work? That did not work. Oh, maybe I think we just do x equals xs and y equals ys. I think we need to do it this way. Cool. All right, that looks good. So we have 1, 4, 1, 4. We see that plotted properly. This is a scatter plot, but it wants a different marker. So I think we can just do marker. I think this is an allowed thing, and I think we can do x like this. This is just something I remember. Cool. And then how do we do a black X? I think that we should look at the documentation for this. So you're going to look up marker. Doesn't have anything. Style. All right, let's look up style. There's no marker here. Change marker pandas plot. How do we change the color? I feel like usually you can do like B for black and then X. What happens if I do? Nope. I think probably there's another keyword argument that we can do as color. I'm curious if this will work. That works. I don't love this. Where can we find all the documentation on scatter plot options? DataFrame.plot. I think it, okay. You can pass in matplotlib plotting method args, so matplotlib keyword args marker, I think is one we can look at. Marker, cool. This is much more helpful. Cool, and this is where we can see that the X is allowed. And I think if we look back and look up color here, like this syntax, this is the third argument. I guess it's the format. But we see down here that like they pass in color. Doesn't show us our options here, but I feel like you could use like ChatGPT or something to figure out all the options. I think if you type in standard type names, they're probably going to work. And we might even be able to do hash colors here. So I might be able to do something like this and get a color. Let's see. 11111. Does this ever change the color? Yeah, that's changing the color. Cool. Cool, so you could do hexadecimal colors here, but black works, that's what we're looking for. That looks good. 57. Columns in your data frame can also be used to modify colors and sizes. Bill has been keeping track of his performance at work over time, as well as how good he was feeling that day and whether he had a cup of coffee in the morning. Make a plot which incorporates all 4 features in this data frame. Okay. Let's copy this data frame in. Okay, and what are we plotting? So our y value, I would think, would be the productivity. X value is days, but it doesn't really specify if this is segmented by each day. Trying to think of the best way to visualize this. What would happen if we just did plot.scatter? Here it would want an x and y. I feel like we want this to just change the marker or something. And this to maybe be how big the marker is. We'll make this like a fill, and we'll make this how big something is.
I don't know if I like a scatter plot being the graph here. Like I feel like there's like a fill, and I can make that the caffeinated. I feel like there's a marker size something, and that could be happiness. I don't know if this will work. I think we're gonna get an error. Okay, fill is not a valid value. I want some sort of outline. Let's see what we have in outline. Outline. Marker size is 1. Line width, I kind of like this. 0 or 1. Let's try that. Line width. Marker size. I feel like marker size is valid. The line width now works. Just curious what this gives us. Can I do DF caffeinated here? It's also spelled wrong here. Caffeinated. Even if I spell it the same as they spelled it, it doesn't like it. That kind of works. I don't see any difference though. But we could do 10 times this. That give us, oh wow, that does look different. Nice. I feel like I like this for happiness though. Maybe do 5 times it. Oh, and I like productivity being the Y here, not hours in. So this should be hours in, productivity is the Y. So I feel like your productivity is kind of dependent on all these variables. And then how can we encapsulate caffeinated? I think that marker size should work. I think if we just did DF caffeinated, it will work. Like marker size is what they list here. Can we just do marker equals? I need to do some sort of like marker type. I could make, like, you could do something like marker types equals np.where df caffeinated. That's a boolean by itself, so where that's true, it's x. Where it's false, it's o. This should, I think, work. I don't know why it's not working. Unrecognized marker style array. Can I make this a list? What the heck? What are other values that I can pass into the scatter plot? Plot scatter options. We could do color here. We can make this color. That's going to be white or black, basically, I think, if we do just 0 and 1. We could also do something like what we just did, but watch, if we make this green and red, and then pass this in as just C, this should work. Look at that. But I feel like green and red don't make the most sense. So maybe black. Like, what would be not caffeinated? This is true. Then it should be like, I don't know, green because they are caffeinated, or maybe brown because it represents coffee. That's an easy way to remember it. And if they're not caffeinated, and white. So maybe gray. This brown does not look very brown. Hexadecimal would probably be better there, but cool. So trying to see if there's any trends. I feel like you're trying to measure too much. My general thought with graphs is you shouldn't measure this many things, but it is cool to see that we can. So like this 2 hours in and 9 level productivity, that's definitely going to be a happy day where you see a big circle around it. But there's not many trends. Like, yeah, and I think we're just measuring too many variables personally, but we did accomplish the task for 57. Let's go to 58. Okay, make a bar plot of monthly revenue with a line plot of monthly advertising spending. This is our data frame. Get DataFrame.head. I think what we can do is we can call df.plot.line of x equals month, and our y is the spending on advertising, so y equals advertising. And then we also want to do dfplot.bar of x equals month, y equals revenue. All right, this creates 2. How do we make this one and the same?
Pandas allows you to pass in a matplotlib axes object for plots. Right. What is a matplotlib axes object? Plot.axes. This is a documentation type question, I feel like. I would probably look up something for this. Plot multiple graphs, pandas. Matplotlib axes object. Overlay multiple 2 graphs pandas. This will be helpful. What does 20 do? I might see if we can use good old pal Copilot to help us here. Use matplotlib axes object to overlay these 2 graphs in the same graph. No, that's not what I wanted. Let's look back at what this looked like. Where does X? Oh, okay. I wonder if this will work. Still 2. something like this. What happens there? Kind of. They're overlaid now. I see something overlaid. But why are these values? I feel like I kind of want to use a different color here. So like the line should be, oh, this is, I hate that it's also duplicating month. The line, let's make the color equals blue. And I wonder if we reverse the order here. And can we actually, maybe we could just use the same axis for both ones. Oh, that looks much better. I don't know what this extra value though here is. It looks decent though. But what is this value here? The y should be the same. Why is there this extra x-axis thing? I don't know, but I'm content with this solution. Let's see what the solutions look like here. Solutions, plotting, scatter. Okay, that's pretty similar to what we had. We just explicitly said x and y. They just use it as the first two arguments because the order matches there. Okay. S is color equals DF caffeinated. Makes sense. We did something similar here. Happiness. What is S again in the docs? Oh, size. The size of each point. So yeah, something fairly similar. We just did it slightly different. Do they use a scatter plot? Yeah, they did scatter. Oh, interesting. Okay, this is how they solve that one. You can set axis equal to this and then specify the axis here. Makes sense. Month is the x in both. I like that they limit it from 0 to 12. Okay, go back to ours. Let's do problem 59. Create a candlestick chart. Okay, so this is mostly a pandas question, even though there's a lot of matplotlib there. Time series grouping function. We would like each candle to represent an hour's worth of data. Okay. So we want to group by, we want to like filter by hours, get a open, high, low, and close for each of those.
I'm confused by this. Ran all this. Generate a day's worth of random stock data and aggregate/reformat it so that it has hourly summaries of opening, highest, lowest, and closing prices. This is day stock data. What happens if we just do, what does this return? Returns a data frame. So df equals day stock data. What does df look like? This is weird. Do I need to change this function? It's not clear here. Oh, we just called the head. I was going to say, why is there only 5 values here? If we look at, yeah, it's much more than 5 values. So now, okay, now we need to aggregate/reformat this. So we can do a group by, I think there's a frequency. Right, let's just look at our data frame. df.info. It's got a time. Okay, and price. If we do df.group by df.time.hour, can we do this? Something like this. Date.hour, can we do this? I think we can. What happens to this if we do this? Okay, that kind of worked, I think. This is the hour. I kind of want to do this on a different cell so we can just keep df as df. Okay, cool. I think that what we were doing does kind of work.
So we did a df.group by df.time.date.hour. And then we just counted the number in each. I don't know what, oh, the sum didn't work because we didn't do it on price. If we summed up, if we grabbed price and then did a sum, that would work. Cool. All right. Grouped df equals df.groupBy. And then basically we want to just add all the information we want. So grouped df, I'm just call this dfg, just because I don't like typing out long variable names for pandas expressions. So open would be the first index, so it would be df equals dfg dot, what is the first index of a grouped by item? Can I just do dfg dot first? Okay, we'll have to look this one up, but I think the easier ones is min. We could do min. What do we want? We want hourly summaries of opening, highest, lowest, and closing prices. So min would be 1. Doesn't. All right. Okay, that's min. This would be max. What can we do first? That's correct. And then I think we can also do last. Cool. So those are the 4 functions, and it's just a matter of how do we fit that all together. I'm trying to think of a good way to do this. Can I do multiple ags? Like first and last here? Oh, wow, that's cool. Learning on the fly. And then min and max. Look at that, that's sweet. That was like pretty straightforward. Okay, that looks good. How does plot candlestick work? It says don't read. Unless you have to. What happens if just we do plot candlestick DFG? Okay, we want to rename, I guess it's expecting a time
Oh, it wants me to maybe reset the index. What happens if I do this? I don't know how to go, like, can you just let me do time here? I'm editing you. That didn't work. Now this is just a matter of changing some names. So dfg dot rename columns equals min over the low. We want max to high. Does it like first and last? Open and close. So also we want to name this first is open, last is close. Okay, now what happens if we try to plot the candlestick? No. Key error, color. Where am I trying to plot a color? That's so weird. Is there's color getting set anywhere? Oh. Color should be red if open is okay. We can do this. DFG color equals np.where dfg open is greater than dfg close. If that's the case, then it goes down, so the color should be red. Otherwise, it should be green. I did this a little too soon. Oh, let's go. Candlestick is being plotted. Sweet. And apparently there's more exercises to follow soon, but I think this repo was posted like 4 years ago. So I don't think those exercises are coming soon, but I guess that's the video. I learned a lot personally, so hopefully these exercises were fun. Yeah, I don't know. Like, you think you're good at using pandas, and then some of these exercises come and humble you. So I'm excited that there was a lot of learning for me personally. Hope you all learned a lot. If you enjoyed this video, it'd mean a lot if you throw it a thumbs up. And subscribe if you haven't already. Also, just let me know in the comments what I should make, what you need more videos on. I have a lot of time to make videos and I want to be consistent, but I don't always know what people want me to make. So let me know. Yeah, if there's any other questions on pandas, skills, or things we covered in this video, let me know in the comments as well. I know that I titled this Solving 100 Pandas Puzzles. I thought we were going to solve 100 Pandas Puzzles, so please don't hate me for, I guess, lying because we only solved like 60, but they were a good 60. All right, I'm going to stop rambling. Until next time, peace out.